Um, well, thank you for joining me today. I'm really excited about this. We're going to be talking about Crossplane, but actually we're going to be talking a lot about Crossplane functions. And you folks are hearing something that is very brand new. This was just released last week, actually like a couple days before KubeCon. This was in Crossplane 1.14. And this is one of those things I am most excited about Crossplane going to 2024, because I think this really completely changes the project into something else that's really exciting. So we're going to be talking about that. Just about me myself, Steven or Stefano, either one you can use. That's my GitHub ID. And I'm a principal solutions architect for a company called Upbound, and they're one of the primary developers of the Crossplane project. So let's get started. Just about our talk. Now, I was talking to folks before, and we have some folks who are very experienced with Kubernetes, some folks who have heard of Kubernetes but don't know what it is, so I will try to accommodate everyone. We're going to talk about Crossplane, then we're going to talk about some Crossplane concepts, and then we're going to get a little more technical. We're going to talk about composition function architecture and data structures, and then we're going to talk about running functions and composition pipelines, and we may have a Go function walkthrough. So some things we're going to be talking about today are Kubernetes CRDs, gRPC a little bit, the Go language, and just a lot of little things within Kubernetes itself. Just so I will try to explain everything I can for different experience levels, but these are the things I expect to talk about. So the first one is, what exactly is Crossplane? So basically, Crossplane is a project that sits on top of Kubernetes. So for the folks who aren't familiar with Kubernetes, Kubernetes is a distributed scheduling system that has pretty much become the standard for like a distributed operating system, right? It provides a standardized API and a lot of primitives that allow folks who are running applications to run lots of applications on a cluster in a very standardized way. Since Kubernetes came out in 2014, it's pretty much become the dominant platform in this space and pretty much wiped out everything else. Before Kubernetes came out, I used to work on another platform called Mesos, which was similar, like scheduling jobs across clusters, and watched Kubernetes wipe that out. So Crossplane sits on top of that. And the idea of Crossplane is that Kubernetes can be extended to manage almost anything, right? So when you look at a Kubernetes cluster, its main concern is things that are running on it. So you have things like a service or a pod or a job or something like that, and you're running distributed workloads on a single cluster. What Crossplane does is it adds another layer on top of Kubernetes, and it lets you manage anything that has an API. Right, so that would include things in AWS, things in Google Cloud, things on your local on-premise infrastructure, and it manages them all in a Kubernetes-centric way. And the way it does that is it uses a technology in Kubernetes called a custom resource definition. Right, so you're going to hear this term a lot in the Crossplane world. It's called a CRD, and it's a way of extending Kubernetes that you could create almost anything on a Kubernetes cluster. So we use that pretty heavily. So this is the technology we'll be talking about. So that's Crossplane. And so what we talk about here is that any resource outside the cluster can be represented by a Kubernetes object, right? So what we mean about that is that for the folks who don't know about Kubernetes, we have API versions and kinds, right? That's the first thing, right? So every single object. So you can imagine here, like the Amazon provider has over 1,000 different things you can provision within it, right? So there's going to be 1,000 different kinds just for AWS. GCP and Azure are similar, 700 to 800 each, right? So you can imagine that there's 700 to 800 of these types on each one, right? Labels, annotations. So if you've never seen Kubernetes, if you're in the Kubernetes space, you know, people are always joking about YAML and things like that, right? Like everything in Kubernetes is described as a YAML object. In this case, every Kubernetes object has a group and a kind, and then it has metadata where you have like names, labels, and annotations. Crossplane resources all support this natively. So what we see a lot of folks here is attaching business units, confidentiality codes and things like that. So they can, query their cluster and say, what resources belong to this business unit, and they can just query it. And then finally, there's a spec, right? So what we have here is, if you know anything about Kubernetes, every object has a spec, which is a desired state, and then a status, which is the state that Kubernetes represents coming back, right? So in our spec, we have something called for provider, and this is where we tell the cloud provider what we want to set, right? So for provider is a high fidelity mapping, right? When you have a managed resource like this, it is as close as possible to 100% what the Amazon API is, right? We can't do everything in a declarative sense, but it's usually as close as possible. Okay. Any questions so far? I could show you what this looks like. Let's see if I can bring up a code window and make it bigger. And you folks, let me see here. I'll make this bigger, right? So we'll hide this for now. And if we look at a bucket, right, this is something simple, right? Like I'm going to call this bucket STL-CNCF. I'm going to put US West. I'm going to put the owner, right? And what I could do here is to create a bucket on a cluster, all I have to do is just apply this. And now we can just watch the status of this bucket. It's already been created. So I'm using a new provider, which is extremely fast. So it's coming out on Thursday. So, but you could see here that we have already in a sync state, right? So every single object in Kubernetes, it's basically the bucket is a Kubernetes object. Now, if we look at this and we describe this, I'm gonna get rid of the watch there. What you could see here is that we have, this is what's kind of cool. We emit events, right? So instead of like running a shell script into other IAC tools and getting like a result back, you could just look at the events on the object. We support Kubernetes conditions, right? So especially things like monitoring systems. So a big thing for Crossplane, like in the end of this quarter, next year, is observability. So we're putting Prometheus metrics in all the providers, and based on our big users. And that means that we're going to have Grafana dashboards that actually could look at like time to reconciliation for every resource across the cluster. So we can monitor things at scale. So you're starting to see how building on top of Kubernetes is an enormous improvement over other infrastructure tools. And then when you look here, you're going to see just a couple things I want you to see just to understand. And sorry about all the managed fields. That's a Kubernetes thing that's kind of... So one of the most important things here is this annotation called an external name. This is the one thing that maps the YAML to something in a cloud resource, right? So like if you're ever backup and restoring, you just have to restore this field, and then Crossplane will take over the object. So if you have a YAML with this field on an existing bucket, Crossplane will just start managing it. That's how you import resources in. Just other things to see. We'll skip the managed fields again. We're zipping by them. So you can see here we have the spec and the for provider. And then we have the status at the app provider that comes back. And here you can see all the things that come back from the cloud provider. So these are all Kubernetes objects, right? So you could query these, you can collect them or do anything you want with them. So this is what we call a managed resource, right? This is one single thing in AWS, and we manage it like a Kubernetes object. You don't have to have a separate tool or SSH into a server. You could just use kubectl to get the status of everything. Yes,
so
question.
Use Crossplane to provision that bucket, or did the bucket
Yes.
It was already existing?
No, Crossplane provisioned it.
It provisioned, okay.
Okay, so what we're doing here is we're putting in our bucket YAML, we're telling Crossplane to create a bucket, right? And if I did kubectl get bucket S3, if I had more than one, it would come back and say which ones I had. So yeah, it's super cool. All right. So yeah, that's the idea, that every single object could be managed as a Kubernetes resource with all the events and, as we said, logs and everything like that. So let's talk about how it works. You're asking, how does it work? So basically, when we apply, and can everybody read this? Is it too bright? When we apply the YAML here, in Kubernetes, you apply it to the API server, right? So we're using the Kubernetes API server. And what's important about this is that for all the corporate users of Kubernetes, they usually have security policies or authentication proxies in front of their Kubernetes endpoints, right? So we just reuse those, whatever authentication your Kubernetes cluster does. So we're not implementing anything new. And then the way providers work is we have a Kubernetes controller for each resource, right? For each resource group, like EC2, which has like 100 resources, has one controller, right? And that controller, when it gets installed, it creates watches on the etcd API server saying that I manage these resources, and if anything comes across the wire, I'm going to go talk to AWS and provision it, right? So that's how it works. So A big improvement of this model over, I did a lot of infrastructure engineering in my previous jobs, and a lot of times this was implemented like in a Jenkins pipeline that you watch a Git change, and then you kick off a Python script that then creates some vars somewhere that then kicks off like another shell script to run a tool. The way this works is the API server handles all that logic, and it'll calculate if there's any differences, and it'll inform all the watchers, right? So this is a much more efficient way of running things. Doing all right? Understand everything so far? Okay. Just making sure for everybody at every experience level here. Cool. Okay. Another thing is Crossplane is a CNCF project. It was donated to the CNCF. And that means even though I work for Upbound, the Crossplane project itself, all the trademark governance security is owned by the CNCF, and it's licensed under Apache 2 license. Okay. And I always put this here because that's where you can see us on the CNCF landscape. I always thought this was like, ever see those things like you see the galaxy and you see you are here, the little arrow that points to it. So I'm like, I had to go find where we were, and I put the arrow there just so we could say, hey, we're on the landscape somewhere. And actually, we're right next to Kubernetes up there, so it's very nice. Cool. So that's the introduction, like a super high level, very quick introduction. Does anybody have any questions so far about Crossplane? Okay, because we're going to start talking about more concepts, and then we'll go in. So the first thing is, you saw we provisioned one resource, but you're probably thinking about, well, what do I do if I have a lot of resources, right? Like there's a couple people here tonight who manage EKS clusters, right? And if you're managing anything in AWS, for an EKS cluster, you're probably going to need like a VPC, you'll need like security groups, you need IAM roles, role policy attachments, all those things, right? And how do you do that in a Crossplane sense? So Crossplane has two things. It has this concept called composition. Now, if you've used other infrastructure tools, this would be similar to like a Terraform module. But there's some differences that I want to highlight. The first one is that you create something called a composite resource definition, which is like a CRD, but it's one that you create for your team, right? So you can imagine I work for mycompany.com, and I'm going to offer up a cluster type. And I only want my users to be able to specify the Kubernetes version and the nodes, the count and the size. That's it. Like, I don't want to give them any idea about roles, regions, anything like that, right? I just want to give them a small API. So that's something called a composite resource definition. And that is just a CRD that you create for your users. So Crossplane, our biggest growth is among what we call platform teams, right? So there used to be like infrastructure DevOps teams that do infrastructure. Our biggest use case is people who are building internal cloud platforms. And we see this, so actually the uptake for Crossplane is really good in like large organizations, right? We're seeing that like a small team of platform engineers want to offer their cloud internally that's configured a certain way to hundreds or thousands of developers, right? That could do self-service, right? Because it's Kubernetes, they could just use whatever CI system they have and go to the cluster and say, hey, create me a cluster, right? And then on the back end, Crossplane will explode all that out and create the composition that provisions all that, right? And then you have all the monitoring and everything as part of it. So this is the core concept of composition. Doing okay?
I'm definitely going to be doing a whole lot more reading.
Yeah, and I actually gave a similar talk to this to a group that wasn't Kubernetes specific. It was more like an open source group. And the feedback I got was that it was a lot of concepts. So I'm trying to, it can be a lot. One of the things is, and I'll show you an example of this, is that users, so how do you get it? Like, one of the questions here is, when a user asks for something this basic, right? How do you get all these values into something that's actually usable on the cluster side? Because you have to configure a lot of things, right? So Crossplane, until 1.14, a couple weeks ago, had something called patch and transform, right? And what that did was, like, the user would ask for, in this example, they're asking for an object store, right? Like, so the company has abstracted out buckets and Google objects and everything. They just say, you're going to ask for an object store, and based on that, we'll provision either on-premise or whatever. And what happens is, the user asks for a region here, and what happens, we have something called a patch, right? And I'm going to here, and this would be in the composition, which is a big thing of YAML, right? And it's going to take the field path, the spec, right, desired region, and it's going to patch it up to here. right? That's how patching works. And when we talk about patch and transform and Crossplane, this is basically how it works, right? So the problem is that Kubernetes is a declarative system, right? So when we talk about the YAML, there's another effect of that. Like Kubernetes doesn't really handle things like variables or loops or anything for you, right? Like you tell Kubernetes the state that you want, and it goes does it. In the case of something like Crossplane, that's not enough, right? Because like we have to know a lot of things. And patch and transform is one of the tools that we use. Another tool we use is we have labels and selectors. So for the people who don't know about Kubernetes, you can reference other things in a cluster, right? You could say, hey, I want to know about object B, and you could either select that by name or you could select that by metadata. You could say anything, I want to select anything with this label attached to it. So a common pattern in Crossplane is to create a bunch of subnets with a certain label and then say, hey, attach all those subnets to my resource, selecting by that label, right? So this is some of the ways that Crossplane gets around the limitations of Kubernetes YAML. And obviously we have patch and transform. What I didn't show here is that aside from patching, you could do things like transform, like a lot of the string functions and things like that. You could do joins and two-upper and all that other stuff. So this was the primary way that folks were creating these complex compositions, right? And rolling out infrastructure. And maybe I'll show an example of this. Let me go. Use this. I'm gonna go to APIs. I'll make this a little bigger. Okay. So when you define a composition, there's two things you're defining: the API and the implementation of that API, right? So this is the definition, right? And what you see here is you defined what its name is, right? So in this case, we're defining a cluster kind, and we're defining what the secret is. So one of the cool things about Crossplane is that when you create a resource that actually has a secret, like a kube config or a database, you can configure what the secret that comes back to the user is. So in this case, they're going to get a kube config. They're going to get a secret with a key called kube config in it. So in your composition, you'll map the kube config that you get from EKS or GKE, and you could give it back to the user in their own namespace, right? So it's automatically all wired up for you. And then you could have things like versions of this API. So this is the API that you offer to your users. So this is, if you've ever done a CRD in Kubernetes, defined one, this is how you do it. It's the exact same way. You could have different versions of the API that you serve out. But in Kubernetes, if you have incompatible versions, you have to have one version is good, and the rest need a conversion webhook to go into it. So this is more advanced Kubernetes that you don't have to do this. You could just have one version, but we also support conversion webhook. So the larger platform teams, if they're iterating on their API that they offer to customers, they could actually convert to the newest version automatically. And this is all built within Kubernetes. And the schema that you define for your API is just open API, right? So it's a data type. So you can see here, we're just saying it's a type string, a region, and some other things here. We can make properties. There's enum supported here. You can see here that we could have default values, enums. This is all standard in the CRD. So one of the really nice things about this is, since this builds upon the Kubernetes CRD infrastructure, is like you don't have to define your own internal validation or file formats, right? You just build on top of this. There's something new in Kubernetes 125 called CEL, Common Expression Language, and you can even add more features. You can make fields immutable at the API level. So it's very powerful, right? So my experience in infrastructure engineering in the past is like everybody would define their own JSON or YAML format, right? This is actually built into Kubernetes. It's enforced at the client and the server, right? So you already have all that validation built in. So you see, as a platform, you have like tooling and everything built in to make this a standard interface. And you can see here enums, right? So we have what Kubernetes version can you select, right? So that's what your API looks like. And when you apply this to the cluster, a developer will come and say, hey, I want a cluster type, and these are all the fields they can fill in. So that's what the definition looks like, and let's go back to the implementation of that. Right, so the one thing you'll see here is that we have a reference, right? We say this implements that API. And the reason we do this is because you could have one API and multiple implementations, right? You can have one cluster API, and you could have one that does it on Azure, one does it on Google, one that does it on premise, right? As long as they fulfill that API contract, that's what they say here. It's like, I fulfill that API contract. So your platform team could have one API that they expose, but in the backend, the compositions could render to different backends, right? So it's very cool. And then you see here we have patches, right? So they're just good. This actually embeds a couple other compositions, right? So there's an X network. So if you look at this composition, it actually embeds like 3 or 4. It embeds an EKS, a network, and then OSS that installs Grafana and Prometheus, by the way. We have a reference platform that installs Grafana and Prometheus.
What I like to hear.
So, and Xflux, right? So this does GitOps, right? So what this does is, so this is a high level, right? This cluster, they have other modules that they've built, one for the network, one for EKS, one for provisioning things onto the cluster. They offer it up to the end user as a cluster, right? And some of the cool stuff we could do is, you can see the patches here and everything, but we take, for the XOSS, what we do is we take the kube config to generate an authentication for Helm, and then that's automatically refreshed and used to provision Helm onto the same cluster. So you provision a cluster, and then Helm comes in and drops all your standard packages on it automatically. So that's how it works. So cluster comes up, Grafana Prometheus on, registers itself with Flux, you're good to go. So this is how composition works. Very high level. There's a lot of concepts here. Like, I don't want to overwhelm everybody, but just to give you an idea of what we see people doing with Crossplane, right? Like, you're a platform engineering team, you're running on top of Kubernetes, you're defining your API for developers to consume, and on the back end, you have this engine that can provision things. Any questions so far? Doing okay? All right, cool. So that's patch and transform. So let's talk about the problems with that. So we've been getting a lot of feedback on this, and there are a lot of problems with patch and transform. One of them is that we can't do things like loops, right? So this has been a limitation of patch and transform, and people have been hacking around some of these. We actually have a Helm provider, so people have actually been like using Helm templates to render out resources and bring them back, and it works pretty well. Conditions. Flexibility. The patch and transform engine is built into Kubernetes, built into Crossplane, right? Like, it's a core part of Crossplane. So if we want to add like a new transform type or new type patch type, it usually takes a few months, right? Because the release cadence is every 3 months. You have to have a proposal in, get that proposal approved. And then finally, it's declarative. There's times that we don't want declarative infrastructure, right? Like, we need to be more flexible. So the solution to this has been functions, right? So this just came out. We've been talking about this in Crossplane for a long time, probably close to 2 years now. Discussing it a lot because, and the reason that we have selected functions as a solution is, and this is the reason why patch and transform was deliberately limited by the architects. We don't want to build a DSL in YAML. That's the #1 thing. We don't want to have another DSL, a crappy programming language that's limited. I'm not going to mention other crappy DSLs, but anybody who's worked in the infrastructure space has probably come across several of them that are not like real programming languages. We want to support complex logic. One important thing for us is we want to be able to write in any language or text processing tool. We want to make it really easy to write, share, and run functions, right? This was a big thing for us. We also wanted to start having like things, I say multi-step pipelines, but we really wanted to have the idea that you could have staggered, right? Like, you could run things in sequence. And then finally, scalability. So this is a big thing for Upbound because, as I said before, the use case that we're seeing is very large organizations are using this as their core infrastructure platform, right? Like, it's, and it's serving a lot of different needs. So scalability is a big challenge for us. And we've been like working on it basically the entire year to get better scalability. So functions have to be part of that story, right? They have to be something that's really highly scalable that could scale to, tens of thousands of resources. So let's talk about that. I alluded to it, but Crossplane, the project, pretty much our entire focus on 2023 has been listening to users and customers and removing roadblocks to production. Like, what is keeping users from getting into production? The first version, so Crossplane comes out every 3 months. The first version of functions came out in alpha last January. And we got a lot of feedback by that, and it wasn't great. Like the functions, the original functions were run alongside Crossplane, and Crossplane actually had like a home-built container engine that would like send a gRPC message to the sidecar function. It was a little harder to program. It was a little harder to debug. So they went back, and that was the V1 alpha. In 1.14 is when the V1 beta came out, and the V1 beta is really good. It's much better. Like it's something I'm very excited about. You know, I barely, and you know, I'm a heavy Crossplane user. I barely use the V1 alpha functions, but V2 I've basically spent moving almost everything into them right now. So they're really good. So let's start talking about it. So let's see what a function is. I showed you that big composition, right? That was a big declarative YAML. Now, you know, that takes all those patches and it just spits out at the end like a big thing of YAML, right? Of all the resources, right? Like you can imagine it's an array of those managed, like that bucket. Just imagine that at the end state of a composition, we have an array of all those resources that get sent to the providers that go provision this, right? So that's what a composition does. What a function does is you have these in a pipeline, and each step in the pipeline can create or mutate resources from the previous step, if that makes sense. So you start with a blank slate, and then each function can either add or change resources on the way. And at the very last step, it goes to the provider, right? So usually the first function or two will be the one that creates all the YAMLs, and then the other functions will like mutate them, say, you know, add tags, add labels, you know, expand the security group. Okay. So what we see here is like the very first function is going to be the one like the old composition that we saw. It's going to create all the YAMLs, right? And maybe the next function is the one that adds labels to every resource, right? You know, and then the third one could be something that does like checks or tests on it. And at the final version, it then goes to the provider. Okay. Any question about this right now? Okay. So let's talk about that. So functions are designed to be simple and process input similar to Unix pipes, right? So this is how functions work, right? Like they take the input, they change or mutate it, and then they send it on to the next step. So in this example, you know, we say to add a label to a resource, right? And we're gonna do this in JQ, right? So we get in a JSON struct, and what we're gonna do is we're gonna run JQ, pipe it through, and with JQ you could add fields and stuff. And on the other end, it's gonna have the label on it, right? Everybody see that? I don't know if that's readable, but we just add this label here. Let me hide that. Right? So it's like a stream processing thing. This is how functions work. And every function works like this, right? So when you write your own functions, whatever language it is, it doesn't matter what language it is. You're going to take in that YAML, you're going to process it or create it and send it on to the next step. You actually send it back to Crossplane, and then Crossplane sends it back to the next step. All right. So this is for folks who don't know a lot about Crossplane. There's a lot of packages within Crossplane itself, right? So we install things via function. So I could show this on my end. Everything I'm doing in my demo here, let me see here. Where's my good window here? Can we see this here? If I did kubectl get provider package, right? Everything at Crossplane is installed like via YAML and things like that. So these are all the providers that I have installed on my little kind box that's just running on my laptop here. I'm going to do everything on my laptop here, right? So you can see here we have the providers, each one for EKS, IAM. And the reason we break up providers like this is because, as I mentioned before, Kubernetes API servers cannot handle more than like 900 CRDs. Okay, and so having a couple thousand will kill Kubernetes clusters, pretty much. EKS does a little bit better, but like GKE clusters will go into maintenance for like an hour and a half dealing with this. So this is why we have family providers that actually break up the CRDs, if you want to know why we do it this way. One of the scalability and performance issues we had to put in this year, because we had so many things that we support, we were killing customers' clusters, you know, when they installed the provider. So you can see here, every single provider comes in. It's just providers. Everything we do is OCI image based, which is Docker images, right? So providers are just a Docker image that gets installed into Crossplane, and Crossplane creates a deployment for you. The same thing as we could do. Okay, configuration packages, or if you're an infrastructure team, it's how you package up your YAMLs, right? Like that X cluster here. You can see here we have network flux, GitOps, observability, Grafana there, right there. And so what we have is we have a high-level platform ref AWS, and it has all these dependencies of other packages, right? So if you're a large enterprise, you could have individual teams package up their compositions, and then you could pull them in from your Artifactory or whatever into a cluster, right? So you can imagine you bootstrap a new Crossplane cluster, you bring in all the different compositions that it needs to provision for a tenant, right? You could say these are the standard builder blocks. And finally, functions, right? So functions are just the same way. You want to, so if you want to install a function onto your Crossplane cluster, you just install a function package. And everything runs. So you can see here, everything just runs as a pod. So there's nothing like really magical about the way Crossplane runs underneath. Everything's just going to be a very simple deployment. Crossplane actually manages the deployments for you when you install the package. So in terms of like operations and things like that, you don't need to run an external database or anything. You just install this package, it runs as pods and offers the CRDs out. Okay. Let's go back. So, and as I said before, all functions are just a Docker image, right? Just like everything else. So you build your function, you package it up as a Docker image in the Crossplane package format, and then you can just share it with anybody within the company or anywhere, right? So this was important to us, making it really easy for people to be able to run functions on their cluster. We have GitHub workflows that basically auto-build for ARM and AMD images. So if you pull a function down, it'll work either on kind or in any processor type of the two most popular. When you install a function, this is for people who are more familiar with Kubernetes, it installs a bunch of things, right? So it installs something called a function revision, which we don't have to talk about here. It's a little more advanced, but like every function has a revision. So like you can see what version is active and what's not. It creates a secret. So all the communications between Crossplane and the function are encrypted using mutual TLS. So the function is going to run as a service on the cluster, right? Well, we talked about scalability, right? The function runs as a pod, and the communication between Crossplane and the function is encrypted gRPC messages, right? So this is like a big improvement in terms of operator runtime and scalability. And then finally, there's a service account here, right? So if you have any kind of security policies or something like that, you could attach it to the function, right? And some people have talked about like enabling IRSA or web identity. The functions are really not supposed to call out, but they can. We have some folks who are doing that. I had a coworker who wrote a function that because they had their Argo environment on-premise and their EKS environments in the cloud, he basically wrote a function to query EKS and auto-register everything into their local Argo CD, right? Just automatically. So there's a lot of really cool stuff we can do. But of course, it's just another Kubernetes deployment, right? That's what I really want to get to. There's nothing really magical about that. So Crossplane, it communicates with each function via gRPC. As I said before, every function exposes a service on the Kubernetes cluster, right? So that's how when we create our pipelines and we have a step in the pipeline to talk to this function, it's going to map it to the service here. And each, so the way it works is we send a standardized request, a gRPC request to the function at the service endpoint. So you could have multiple pods running at that endpoint if you want scalability, and your function is supposed to return a gRPC message back. And the folks who don't know what gRPC is, that's protocol buffers kind of designed for web traffic, right? So protocol buffers is like a communication standard encoding data for the wire. gRPC just has that exposed. So the nice thing about this is with the gRPC endpoints is that we could generate SDK clients for any programming language, right? Your SDK, you could write it in Python or Go. Somebody wrote a Q one. There's two actually implementations of Qlang right now. So basically any language that you like, C#, if we can get it running in a Linux runtime. Yeah, so your function just has to, and usually the SDKs handle all the gRPC stuff for you, right? Like when I show you the Go SDK, basically, you don't have to know any of that. The Go SDK basically takes care of bringing up the endpoint, listening on the gRPC endpoint, and then all your function has to do is your function gets invoked when it sees any traffic. So you as a function writer, basically, you just fill in the function logic and everything else is handled by the SDK. So they're very easy to write. And usually most functions are under 200 lines of code in Go. That's what I've seen so far in my experience. So they're super easy to write. Not super easy, but you have to know some Kubernetes internals, right? Like there's a lot of Kubernetes internal data types that they're there. There are a lot of them. So, but yeah, this is how it runs on the cluster, right? So this is one of the big changes in design. And it's a huge improvement, right? Like this is really a nice design. And you can see here, this is actually might affect the future of how we do providers. Because right now we have providers running in a pod, and that's not super scalable because Kubernetes doesn't really do well at sharding workloads that are watching. So one design is to actually split the pod into two parts. The provider, one that just has gRPC endpoint for talking to the API, and the other half that talks to Kubernetes. So then we could run like 1,000 provider pods, scalability. So you could start thinking about, I don't know if that's feasible, but it's one design that's being discussed. So, you think about really high scalability for these kind of systems. All right. We doing okay, everybody? All right. Okay. So let's talk about this. This is a protocol buffer definition. So if you've never seen this before, you define message types, right? It's like, this is the message I'm going to send across the wire. And then you're going to say what's part of that message. So in this message, we're going to say there's some metadata that we attach. Then there's the observed state of all the resources. So this is going to be an array. And this is desired state. And then there's some input that you could have that's a Google that you could add to the function, right? So this is the protocol. And this state is just there's a Google protobuf type. I don't know if it's here, but there's a Google standard protobuf type that maps to Kubernetes objects, right? So the state is just going to be an array of those things. That's it. So in your programming language, you will translate this usually to something like a JSON map or something like that. And then you just mutate the JSON map, spit it out the other end, and your function's done. Okay. So this is what it looks like. You could see here, you get an observed, and you see a desired. So the observed is what the user is asking for, and then the desired is what you're going to spit out from a previous version. So you see here, you have the desired composite, and then you're going to have an array of all your resources, right? So this is truncated here, but you can imagine this resource array is going to have, it's a mapped key, and it'll be every resource will have its own unique name. So like if you have a function later on, you could actually refer to something previously if you know the name, right, and mutate it. So you can have just like a patch later on that just says, hey, I know this resource was created before me, so just patch it. Right, so this is how it works internally. So I just want you to think about that. Like, so as a function writer, you're just going to mutate this and say, hey, I want to create 6 of these, right? And then spit it out the other end. Yeah, but the most important things are desired and observed. So observed is obviously what's out there already on the cluster. Desired, it starts from 0 usually, and then your functions build it up. And at the end, that's what goes, and it's going to be the desired state. Okay. So let's talk about the other part. How do we actually invoke these functions, right? And that's something called the pipeline. So I showed you before that big blob of YAML in the composition, which was just a whole bunch of patch and transforms on an array of resources. It's slightly different in the new function world. We have something called a pipeline, right? The same type of composition, and we have multiple steps. Right, so you're going to see step 1. If anybody's used like GitHub Actions or something like that, other CI tools that are YAML based, this is very similar, right? And so what you do is you have a step, and then you name that function ref is going to be when we installed the function via package way back for it had a name, right? It's going to refer to that function. So whenever it sees this name here, it's going to go use that endpoint and send the message over. And then we have an optional input, which we'll talk about, how you can configure it. You can have custom data that goes into it. And this one here is going to do Go templating. So we have a function that actually does Go text templating. So instead of using patch and transform, you could just embed an inline Go template. Use the variables coming in, like do all kinds of Go text templating, and then spit it out. Right? So suddenly you don't have to, it's like, it's pretty cool. And then on this one, we have a step that validates resources, right? So it'll take the input and it'll validate it using the common expression language, which is something I'm working on, actually. I actually have a unit test framework that uses CEL underneath so that you could validate at the last step of a pipeline. You could say, does everything have a label? Is everything not using a default provider config, right? So it's super powerful. You can have this in CI tools too that you could say. So there's really like incredible possibilities that have opened up because of this. And the velocity of things we can do now versus what we could do before is enormous. Like it just, the stuff we're pumping out like weekly now is incredible, actually. So that's what a composition pipeline looks like. And thank you for following me. Right. And I said here, each step references. You could have as many steps as you want, but usually there's a handful.
This is the recommendation to use this rather than the CI framework.
It's not to replace a C. So I could say as a long-time Crossplane, I would use this rather than the traditional patch and transform. I would move everything to functions. I actually wrote a tool that takes your existing compositions and migrates them over. Like it just will process the YAML and turn it into a function, like Invocator. So I can tell you that I work pretty closely with the solutions architects team. That's the team I'm in. And we are all very aggressively moving towards this just because we all think it's super awesome. And we're seeing really high pickup from our users, which are usually very slow moving, like these large organizations, but a very high percentage of them are already like developing and using functions. So we've seen very high take up. That's why I'm very excited, which is why I'm giving talks about it, because I personally think it's awesome. But yeah, I wouldn't use this to replace the CI system. This is just to do stuff within Crossplane itself. I mean, you could like do, it's. Yeah. Yeah, and you could call out, like we haven't enabled it yet because they're being very conservative about it, but since this is a Kubernetes pod, you can, in theory, integrate it with like web identity and IRSA and EK and just have it like call out to endpoints. One of the issues there is the security, that we have these things sitting out there. Any composition could use them, so there is some security things we need to think about. But yeah. You can, I think there's a use case of one thing of just like querying everything, like having a generic querier in AWS, right? And then just to like pull in references to other things outside the cluster. All right. What time is it? How are we doing time-wise? Are we good? We could talk about writing. I could do a demo of a function here, just of something I was just writing, because patch and transforms, we said they didn't have conditionals. I have a couple functions here, actually, I've been working on. One of them is function unit test, right? And so if you don't know anything about CEL, it's a common expression language that is present increasingly within Google products and especially in Kubernetes, right? It's very like an embedded language that you could use to state something like, does X equal Y or something like that. So all CRDs use it. I actually wrote a function that unit tests things. Right. So what that does is, and I don't know if this is visible to folks. I have a function here that's called, and this is just a dummy resource, but the first step of the pipeline is I just create a couple resources, right? And you see here they just have fields and everything like that. And then the next step of my pipeline, we'll just see the resource. We have a unit test function, right? And each one we have a bunch of assertions. Right, so we're using CEL in this. So this would be the last step for like a CI pipeline. What we're going to do here, we're going to say, hey, we're going to assert that this environment is dev, right? So we're going to look at all the fields within the compositions. And CEL, you could do things like maps and filters and things like that. But we're just going to create a bunch of assertions. We could have tests that fail. We could have here that a certain type of resource is a kind, or we can just see assertions I'm playing with, or that all resources have a specific label that's like security setting. Right, and we could have this as the last thing of a pipeline and just unit test things as they go, right? So that's kind of one of the ideas of a function, and I was able to write this fairly quickly, like, in like half a day or something. Just based on, I had some CEL libraries from other stuff I was working on, but the function itself is not, and I'll talk about writing it next, but just like looking at what the function is itself, if we just go to the code of the function itself, and this is like, of course, Go, I don't want anybody to, I just set up an array of test results. And then what we do is the main thing your function has to do is the SDK will call this for you whenever there's a message that comes in. So you don't have to do anything else but fill in this run function. And what I do is I get the input. And then what I do is I convert the input to CEL, so it could be used, and then I just go through all the test cases and run the assertions, right? And that's pretty much the whole function. You know, there's obviously error checking and stuff like that, but the function is 102 lines of Go, which is very wordy, and that includes imports and everything, right? So in 100 lines of code, plus the CL library, which is over here, which is not, you know, a little bit more, but I have basically unit testing on fields in a composition, right? So we're using this in our, you can imagine this in a CI pipeline. You know, you could test everything, like are your security policies being held or anything like that, right? So you can see these are very fast to build and they're very powerful. We'll hide that one. And then we'll talk about writing a function in Go, but maybe when I put this talk together a while ago, I didn't have as many functions written. Let's see here. I have one too. This one is for blue-green deployments. So patch and transforms, we said, didn't support conditionals. I'm again using the CEL library because I've been experimenting a lot with it. This one actually implements CEL at the composition level. So this means that the entire thing is conditional, or every resource can be conditional. So in this case, this example here is we have a blue-green deployment, right? And you want to say, hey, do I want to activate blue or green at one time, right? And then it'll automatically, you know, it could switch them both on or turn both off automatically based on the composition. Let me see here if I can make this a little bit better to watch. Let me see. Is it full screen? I'll see if I could tile this. So what I'm going to do here is I'm going to do a new command too that's in Crossplane, which is called trace, which actually lets us see the representation between resources, right? So what you can see here is, I'm sorry, let me make that a lot bigger for you, right? So what's happening here is we have the top level, and then you can see there's a tree of all the sub-resources, right? And this is I'm just watching this. So this is being updated live from Kubernetes. And then what I could do here is I could say, if I look at my XR YAML here, you know, I think I could set green to false here. So if we do, right, it immediately turned it off. It stopped rendering it, right? So you can have blue, green. You could say blue to false too. We're going to shut down the whole thing, right? And if we apply it again, it should turn off the other one, right? So then you can imagine this is a use case. We have people with AWS node groups. Sometimes node groups in AWS require to be destroyed and recreated for certain parameters that are changing. AWS is working on this, but there's still a lot of things. So we're working with people to set these kind of things up, that they can just bring up conditionally different AWS node groups. And you see it's all done on the fly, right? So they can just do conditions, and this is all live and everything that it's doing it. Now, obviously, this is much faster than a node group, which takes a few minutes to bring up, but that's kind of like the power of a function, right? Like I was able to write this. And it's actually somebody from the outside with a company that we're working with actually contributed the per resource conditions in about like 10 lines of code. So now we have something that's like really cool. Like, so it's a very powerful framework, right? Like just, you could see how much better it is than our legacy patch and transform that we had. All right. Any questions so far? Because then we'll get into some Go code. I've already been in there a little bit, but all right. Yeah, people learning Go. Some people are pretty strong in Go, or I'm actually gonna. I don't know if I'll show this function, or I could, because I've already talked about some of the other functions. But the idea of this is like we're gonna write a function that adds labels and annotations to every resource, right? Like, so you want to have a function that a lot of companies have required labels on Kubernetes objects, or they get deleted out of the cluster. So if we had a function that automatically added those and said, you know, we created this resource, you know, track it back to this claim, right? So that's the idea here. Instead of doing this in some other tool, just drop a function in there and handle it for everything. So the first thing we want to do is that there's a function template Go out there, and you just clone it, right? And I know this is a lot here, but these are kind of the steps that you have to do. The first one is kind of Go. For all the Go people out there, you need to set up your local mod file to represent your project, right? Like, so when you have a Go module file, you need to point it to your local Git repository, right? So that's the first step. The next one is you set up your inputs, right? Like what's my input to the function going to be? And this is going to be like a Kubernetes type. Go generate will skip. Then you add your function, add some tests, and then build it and push it, right? That's basically it. So really just a little bit of Go boilerplate, a little bit of Kubernetes boilerplate. We do code generation a lot in Kubernetes. If you don't know about Kubernetes, we do a lot of code generation for all types of things because every Kubernetes object needs certain types of fields. So there's tons of code generation to generate those fields automatically for you. We also generate the CRDs automatically out of the Go code. So this is a very common, so those 700, 900 CRDs that get installed, as part of a provider, those get automatically generated from the Go tags, right? So I created a project that just adds labels and annotations to everything. So let's go through this. Yeah, I can actually go back. So the first thing is, if you haven't seen Go before, we're going to add labels and annotations to every object, right? Labels and annotations in Kubernetes are just a map of strings. So if you don't know Go, this means that this is like a hash map. The key is a string, and the value is going to be a string, right? So we're just saying every single label here is going to have a key and a value, right? It's going to be a map of those. So that's the input that we define. So the user who's using this function is going to say what labels and annotations they want to add to each resource. And if I go to the previous slide and I look at my repo, we could actually look at what that looks like in the Go code. It's still there. We're going to go to our input. We're going to look at our input Go here. And you're going to see here, I set a kind. This is all Kubernetes code generation if you've never seen it. You don't need to know it for this talk. Just glaze your eyes over. But you could just see here, I just have labels and annotations. That's what I'm defining. Okay. The next thing is we're going to process the input stream, right? So what we're going to do is we have an SDK.go, and I already showed you that run function that gets invoked. What I'm doing here is I'm going to get all the desired resources that have been desired earlier on the pipeline, right? Because like we have a pipeline that's created these. This would be run towards the end to add labels to everything. We're going to go through each one, and then we have functions within Crossplane that adds labels to things. So I'm just going to say add labels and annotations to each resource. Then I'm going to set the desired composed resources for the response and spit it back. And that's basically the entire function, right? There's like some boilerplate, but that's basically it. So it's basically like a Unix pipe. You go in, you can write this in Python or WebAssembly or whatever you want to do. It doesn't matter. As long as you can talk gRPC, you can have a function, right? So if we look at my code here, if I go back to my code, we're going to have a little fn.go. That's the one that you care about. All right, we're going to, and there's lots of text here, but if you really look here, we're just going to get our desired response, and that's basically it. So this function is 72 lines of code with lots of comments, right? And this will add labels and annotations to everything. And of course, I'm writing a tag manager now that will automatically do this for tags in cloud providers, right? So the cloud, you can manage tags outside of your user's control. So that's basically it. Super easy to do. You can manage resources now, and as a platform engineer, you can do all kinds of really cool things to things that you're provisioning in a very easy way. All right. And as I said, very much like a Unix pipe. You know, text comes in, you process it. We use something called server-side apply. So if you're not familiar with Kubernetes, this is a way of managing fields. Remember before when I said all that junk about managed fields in the Kubernetes output? That's actually part of server-side apply because every field has an owner, right? So you can have like how fields are updated and owned. We use server-side apply by default within functions. So this is a very modern approach. Crossplane itself doesn't use SSA yet. It's coming maybe next January. And then let's talk about the main.go, because this is the Go SDK, and every SDK will take care of this for you. Basically what it does is, and this Kong is just a CLI library, it's not the Kong API gateway. Basically what we do is when it's set off to run, it serves at the function, right? So what happens is whenever a request comes in, it's going to invoke that function. And then we just say listen, TLS, and insecure. So we have two settings, the TLS certificates, which are created automatically for you by Crossplane. and whether it's insecure or not, and debug mode. So that's basically the SDK for the function. You don't have to do anything about that. You just write your function, and everything else wraps that. Well, oh, sorry, what? Yes. When you install, yeah, it'll manage. It sets up the mutual TLS for you. That's part of the package manager that does that. All right, well, I think I was showing our examples already, so we already kind of did this. So yeah, basically, I'll just skip through this. All right. I'll get to my summary here. Yeah, really. I know you can read this here, but like functions, just, functions mutate data and pass it on, right? Like they're not storing data, they're just mutating it. It's a really powerful model, and it's still new, so we have lots of people testing all kinds of corner cases right now, right? But we're seeing a lot of velocity with functions that people are writing them quite a bit. Compositions now are composition pipelines, right? Like, so you have and so far we haven't seen anything more than like 2 or 3 steps. People aren't doing anything too complex. So even though the pipeline is there, folks are not doing anything too crazily complex. We said here, Crossplane will create the deployment and TLS secrets to be used with it, and enabled in Crossplane 1.14. So Crossplane 1.14 came out November 2nd. It's probably one of the biggest releases we've ever had. It has incredible, like tons of amazing features across all of the product. Like it's really good. I have a huge document about it, which I could point you to, like, because I went through and documented almost every feature of it. It's really good. I'm very excited about it. Like Crossplane's been pretty good up to now. We've had good traction, but I feel like this is really going to push us in another dimension in terms of like, this will be the platform that people will build their infrastructure on going forward. So that's my personal belief. I don't know, but it's super powerful. Yeah, and just some example functions. So just to show you this patch and transform, this took the engine. So this is why it's kind of cool. This took the engine out of Crossplane. So Crossplane used to have this embedded engine. We ripped it out and put it in a function, right? And now the plan is to deprecate the old engine, move completely to functions. And I showed you my conditional one, right? Like, so I was able to just fork that, write my own conditional function, and people could swap in my conditional function over the patch and transform, right? So if you're a company and you want like some feature, you could just fork it and have your own patch and transform function, and then see if it gets, picked up. So there's lots. You can have very rapid development. Another function that's really good is conditional. The one I wrote, Go templating. This one you could see here, they're going to just put an inline Go template right there, right? So they could just, if you have any Go templating, you just drop it in line and it could just render out the YAML that way, right? So you didn't even have to do a programming language, just drop in some templating there. So a lot of people use Helm for this right now. You could just do this instead, and you could just have your conditions and loops and arrays and everything. So again, this is also allowing people who don't code to have more access to build these things, because you could just put in a text template and whatever is required. Unit test, which I showed you, and finally, my coworkers, he might have moved this already, but we just had, because I'll show you the render thing, but because functions can be run locally now, we have something called render, and I'll show you that in a second, that you could run functions in the command line to render them in advance, part of development. So what we've done now is we're starting to implement that into our CI workflows. Like, so we had the unit testing one. This is another one where you put it in a GitHub action, and it will go and actually put what will change as this composition as part of the PR, right? So you could think we have now unit testing, and now we'll have previews, diff previews of what the function will render differently in the composition, right? So when I was saying that the velocity is crazy, like all this CI stuff is coming now, so we're going to have a very strong CI story for infrastructure, right? You'll be able to see what fields would change in your function. And we'll do some other things like validation, and I'm planning to have a function that does actually validates against a CRD, so that since every object is a CRD, we're going to have a function step that basically at the end of it will validate that it all renders to valid Kubernetes YAML, right? So before you even configure this package and ship it to your users, you'll have a test suite. Your internal platform team who's developing these things will have a whole test suite that they can, have tested configurations that then they ship as a package on their platform. This is our X network version 1.1 that's been tested this way, right? So you could start seeing the platform being built in a very stable way. So there's just really a lot of cool features. All right. I think that's it. I mean, so getting involved, there's a SIG compositions, there's a Crossplane Slack, you should join it. It's there's a discussion, there's a design doc, which actually goes all of it into it. And then there's some, you know, you could clone the template, but you could actually like read the design doc, which is really good, like telling you how everything works and everything, if you're into this kind of stuff. But yeah, you can see here the original design and everything. So this is, yeah, I think that's most, thank you. That's most of my presentation. So, thank you.
How does it handle like tear down of resources? So like you use it to create a bucket or
Yeah.
you use it to create a bunch of stuff. So if I let a, you know, developers go out and, you know, build a quick test cluster or whatever so they can go test something and then they decide we're not going to go forward with that project, how easy is it to go out and make sure that those resources are cleaned up?
You just delete the Kubernetes object and they'll delete it for you.
Okay.
There's actually something called management policies that we have that are observe, update, create, delete. So you can have on each resource, you could say whether Crossplane is able to delete it, able to update it, or just observe it. So we have like observe only. So it's really cool. So, but the default behavior for Crossplane is if you delete an object in Crossplane, it deletes it on the cluster. It deletes it in the API. Yeah, and you can see here, like I didn't show you like a live composition rendering, but we have, sorry, I got that little window be my, you know, trace, right? And then we could just watch this. Like you could see, so we didn't talk about dependencies. So some other infrastructure tools have like a DAG that they pre-calculate. Crossplane acts like a Kubernetes. So basically what it does is, if a resource depends on something else and that resource is not ready yet, it's going to wait. It's going to keep trying to provision. So what you can see here is that we have our X network. This is something a little bit bigger. And you can see we're creating a VPC internet gateway subnets. And you can see here that like the VPC is true and available, but you can see the top level, it's saying that we're not ready yet because the internet gateway route table and 12 others need to be configured. So we're actually going to watch this in real time, how everything goes configured. We're just watching the events for every single individual resource. So we're not like looking at a huge Terraform state file or querying this. We're querying each Kubernetes object. We're tracing it because every object has an ownership, right? So for larger compositions, you could actually see this be nested. And you can see here, it's going to say like these things will slowly get reconciled as they get, so now this one's creating, right? So the next time it watches, it'll probably be true, right? And this is very fast actually, because it's a new provider, but yeah, so this will, in a couple minutes, everything will be available. So that's what it looks like in a composition. So if I delete this, we'll let it get to ready, and then I'll delete the top level composition and everything will get torn down. And that's basically it. Right, we'll let that create. So yeah, it's very cool. You can see everything has a individual Kubernetes object and a kind. Yeah, we're almost ready. We got 1 or 2 left. Yeah, it says a route table association. Yeah, so this is a new feature, 114, this Crossplane CLI. It's very nice for tracing. It also spits out dot output, so you can actually like graph all these things too via the CLI. Yeah. Who's left? Our route table association. But yeah, and I'll tear this down in a second once this comes up, and then we'll watch it again. Actually, I could tear it down now. It doesn't matter, but yeah. Any other questions while this is going? That last one, I don't know why it's not created.
Assuming you have to have the providers like configured at install time. So like I'm assuming this is you're using an AWS provider to provision all this information. So when you deploy Crossplane into your cluster, can you like how do you provision providers or how do you add providers?
So there's a number of ways. There's a provider package, right? Like you could just install the YAML for one provider. Okay. And the other thing is we have configurations, and configurations could have depends on, right? So when you install, like let's say you're a network infrastructure team and you want to package a standard network, you could put depends on AWS provider of EC2 and VPC, right? And then when the configuration installs, it'll install those 2 packages for you.
And then when you have errors in provisioning, I'm assuming you just see them here.
Yeah, you just describe it. Okay. You describe the object. So we created it now. So let's kubectl delete f network xr.yaml, and we'll see. We're just gonna get managed now because I think that top level resource is already gone. Hopefully we could catch it. Manage is an API. Everything's already almost gone. So it got deleted in the time that I was able to do it. And then just a bucket that we created before, right? So we could delete this one too. Clean up, so I'm not charging anybody anything. Yeah, I think really with functions, it's one, the new providers that are coming out. So just to give you an idea of how the seat's done. So the way our providers worked before was that we were using something called Upjet, which was basically wrapping Terraform into a Kubernetes controller. And it had this Terraform CLI in the middle. And unfortunately, that thing is super inefficient. Like Terraform's very powerful, but with like over 1,000 resources, the CLI was getting very bloated and it was killing us. So we've created something called a no fork provider, which basically skips the Terraform CLI and goes straight to the providers via gRPC or whatever RPC mechanism that Terraform uses. The RC, the full production release for AWS, should be coming out, we hope, Thursday. I'm testing the RC2 of it over here, and it's super fast. You can see that like these things are provisioning and tearing down very fast. So this is going to be very good. This combined with the functions is really feeling like a very good platform. Yeah, just to show you the providers that I have. Right, I'm all running. You can see the version there is I'm running RC2 over here of the AWS providers. So, and I have a Grafana provider. Grafana actually has their own provider. So this is the cool thing. You could actually configure Grafana dashboards via composition. And so then you can spin up Grafana and then you can have your dashboards, and observability is going to be a big thing. So you can imagine eventually all your resources will be seeing how long they take to provision, how many are unhealthy, how many are not, what kinds do you have of each kind, right? So we actually have a SIG observability that is just focused on what are the most important things in observability for Crossplane. So I don't know any other infrastructure platforms that are going to have this kind of stuff, right? So like when you look at it, so I worked in a lot of big companies. Like when you look at what this platform does in terms of infrastructure provisioning, there's really nothing that's close to it right now, like in terms of capabilities, since we are part of Kubernetes and everything. So it's very cool.
You mentioned that you're going to have the tracing in that, the open telemetry.
Yeah, did you see the SIG observability that we have? I'm not sure, what's the plan for that, but yeah.
Okay. Yeah, no, because I was thinking that would be kind of cool. Yeah, if you can view it in Jaeger or Grafana Tempo.
I know somebody's asked for OTel support.
Yeah.
I just don't know how far it'll get into the providers or not.
Yeah. Okay.
I think, now's a good time to join the observability SIG, and they're meeting every month. There's a lot of big users who are interested in this, so.
No, that would be cool.
Yeah.
Otherwise, I guess, I mean, ultimately, you could probably put the OTel stuff in the functions that you write.
Yeah.
So if you wanted to put that spans there for that.
Yeah, part of GA. So functions are beta right now. We use the Kubernetes versioning. So this means that the API is early, but the implementation has to be, but one of the GAs is going to be Prometheus metrics for functions. They're not there yet, but probably for the January 1.15 release of Crossplane, they'll be in. So, yeah.
Especially when you're talking about Terraform and other IAC tools, are there any, is there any tooling to convert like existing Terraform code into something like Crossplane?
Not yet. We have a Terraform provider that actually will like run modules for you within Crossplane, and we know a lot of people are using that. But it's something I've been talking about at least, because especially at KubeCon, that's what most people came up asked us. Like, I have 5,000-10,000 lines of Terraform. I'd like to move it to Crossplane because I'm a Kubernetes person, and I don't want to have a whole other separate pipeline when I could just have this in CRDs that I give to my devs, right? Like, can I do something? So right now it's provider Terraform. Yeah, so, but I think maybe 2024 we'll have, I don't know. I haven't seen it on the roadmap yet, so. What? A lot of people are talking about it. I haven't seen it. In terms of our priorities, I haven't seen it yet. How's that? Maybe.
So I guess just to make sure that I'm kind of understanding how that works, like, so you would just have like a Kubernetes cluster for like your platform team or whatever.
Mhm.
That you're basically use Crossplane to build other clusters and manage all of your resources. Okay.
Across any resource, right? And you have something like Backstage or Argo CD. Like what we see a lot of people using is Flux, Argo CD, and Backstage, right? That's the portal that they give. They have, and Backstage is a little clunky. It's not really great. It's not really an IDP, which is a developer platform, right? Like it's not, but a lot of people are using it, right? So they go in there, they have all their fields, they order it. Usually that ends up creating something in GitOps. So for Argo CD or Flux to provision out to the cluster. That's usually what we see people doing right now. So Argo CD will say, talk to Crossplane will say, hey, provision me a cluster, and then Crossplane will go do it. And then, so that's kind of the platform we see emerging, right?
You said that like a user would start from Backstage and say like, we want a cluster, and then Backstage talks to Argo CD, then talks to Crossplane.
Yeah, because it's GitOps, right? So something needs to drop the Git files. They get generated from the user, they get dropped into Git, checked in, and then Argo picks it up and goes. The GitOps is not necessary, but a lot of companies are using GitOps. We have some products at Upbound that automatically configure themselves from Git, like just you bring up, because we're designing things around having multi-tenant, right? Like we want to have really like hundreds of, each dev team would get their own little Crossplane that gets packages like the configurations, and then they authenticate using things like web identity, right? So they never have credentials, the end user. What they do is like they may bring their own IAM role, right? And then Crossplane assumes that IAM role for them and provisions on their behalf, right? So that's kind of what we see most people doing right now. Lots of assume roles, lots of web identity across a different cloud. We even have a use case of between AWS and GKE, we could set up a federated web identity, right? So Crossplane can use OIDC to talk to GKE to provision things from AWS. So yeah, well, there's like a lot of cool stuff here, that we can do. So yeah, it's.
So Terraform, puts a heavy emphasis on like state files. So you have multiple people working with Crossplane. How does that work? Would they overstep each other, or is Kubernetes like your state manager?
Kubernetes is state manager because etcd handles all of that, and with the managed fields now. So all the server-side apply to managed fields was try to make Kubernetes who has ownership of what fields within etcd, right? So every resource is its own Kubernetes object, right? So if you have 1,000 resources, there's 1,000 things in etcd, right? And usually every resource has ownership. Like, so there's like how we could trace everything. Everything has an owner reference of who owns it. So you can't take ownership of something else. You can maybe modify the fields or whatever, but if a controller owns that, unless you but in general, you can't. So yeah, Terraform has like a big state file that locks and stuff. In Kubernetes, it's really the API server and all the RBAC around that and ownership that manages that. So usually there's two-sided, right? So people coming into the Kubernetes API get in from RBAC, all the requesters, and then the providers talk on the other side and are like sending updates of the real-time state. So there's less of that kind of locking thing that you get with state files, which is a big monolithic thing. Yeah. Dave, did you have it?
I got a lot out of this. Several things I need to start doing differently. My work is very much in the Microsoft realm.
Mhm.
We've been doing things with Azure. Kubernetes is obviously something that you can do inside Azure. And I could use what I learned tonight to help bring several teams forward 2 or 3 iterations of maturity.
Yeah.
So I got a lot of reading to do. And I got a lot of people I need to talk to start getting them looking at different ways of thinking about how we can do things in a better way.
Yeah. It could be a big jump because there's a lot of organizations that have a ton of people do click ops, what we call it, right? Like they go into the console, they provision, right? And now we're saying, well, you're going to build this platform that has an API that is integrated with a developer platform, right? And you're going to have software releases of your platform, right? Like, so you can imagine it's kind of a high bar, right? So it's definitely people who are comfortable with Kubernetes and cloud, which is a tough mix, but those people are the most enthusiastic about it. But yeah, we've had some really good success, and that was even before all this new stuff is coming out, and the new stuff is just like really powerful for, I think with the observability, all the functions and the performance things, I think it's a really good foundation to build a platform on. So, yeah.
We get configuration drift is like a big issue with Terraform. Like resources that stay on forever, and like somebody will go on the EC2 instance and just increase like the volume size or whatever.
Mhm.
How does that work with Crossplane? Is it continuously monitoring and then
Yeah.
does it resize to the back or? Okay.
Yeah, if it can.
Okay.
If it can't, then it's going to get stuck. But in general, so there's two differences. So Crossplane runs all the time. So it will constantly reconcile. And usually the pull interval, and it'll start backing off if it's been stable. Usually it's like 10 minutes to an hour. It'll go back and check. If it does detect the difference, it's going to go override it. Okay, so this is desired state in Kubernetes. It goes like what you say you want is what's going to happen.
What you explicitly
Yeah.
do is what it's gonna
Yeah.
honor.
Yeah. Now we have all the CI stuff now. There's not a dry run right now, but part of the thing that we're talking about, that gRPC split of the providers, is to enable that you could actually have a client talk directly to the provider and see what the diff is. So a part of it. So this is one of the designs we're thinking about. So that's probably something. I don't know when that's coming because we're still trying to figure it out. But I would say sometime next year we'll probably have something like that. Yeah. Any other questions? That's a lot.
Thank you again.
Yeah, thank you. Thanks. These were great questions, so I really appreciate it.